Hello everyone, my name is Mitchell Rice and this is the second lab in Physics 2212 where we explore lines of charge. Alright, as an introduction to this lab we explore electric fields of tapes using line charges this time instead of point charges as in lab 1. We continue to explore these two tapes in equilibrium, equating the gravitational force and the electric force in equilibrium, but this time we're using line charge to calculate our excess charge instead of the point charge system previously. All right, with all the calculations coming out, we got an excess charge of 2.268 times 10 to the negative 8 coulombs. And all right, now moving on to principles. Many of them we already used in the previous lab, such as Coulomb's law, force due to gravity, electrical force, and gravitational force in equilibrium, and the interactions of different charges. However, in this lab, some new principles, or the new principle we used was electric field in relation to line charges instead of point charges. All right, moving on to the experiment itself. So of course, the system being the top tape in this experiment, and the surroundings the surroundings included the bottom tape. The top tape had two forces acting upon it, being the electrical force from the bottom tape in the positive y direction, and the force of gravity downward on the top tape in the negative y direction. Some common values that were important in this were that both tapes used were about 20 centimeters or 0.2 meters long. And also another thing, this experiment involved bringing the bottom tape upwards until you reach equilibrium, and the measured value that we got in this lab was 0.023 meters. All right, now moving on to the calculation of excess charge. We used the equilibrium equation where we used the force of gravity and equated it to the electrical force. So here you have mg equal to the Coulomb's law equation for a line charge. And then below that, I've listed out the common values that we need to equate for, or to calculate the excess charge in a tape. So after plugging all those in, we got a value of 2.268 times 10 to the negative 8 coulombs. All right, some assumptions and approximations that were made in the matter of this experiment were that air resistance on a moving object was ignored. Yes, it was ignored because it was impossible to measure, and it was just included as part of the experiment if there was air resistance. Also, each U-tape, it was assumed to have the same amount of charge, and it was evenly distributed across the length of each tape. And then, obviously, in Lab 1, we treated each tape as a point charge, but we didn't do this in this experiment because we wanted to explore line charges. All right, here's my glow script model. As a basis, we have the red top tape, evenly distributed charges up there, the blue bottom tape, surroundings distributed evenly. The yellow force downwards is the gravitational force in the red tape, and the white is the net electrical force upwards, summing up all the green components where the distribution of charges pointed upward. All right, here's my glow script code. As a brief run through, we have the physical constants, the mass of the tape, the calculated excess charge on the tape due to the line of charge, as I talked about earlier. These two functions equate and loop for the electrical field from the bottom tape continually along the line of charge. And then here later in the script is where we add them all up and equate them to vectors as seen in the original figure. All right, as a conclusion and a couple discussion questions, what if the model tapes had a single or acted as a single point charge? Obviously, it would act as the original Coulomb's law equation. We'd plug it in, solve for excess charge. And as in Lab 1, we would get 1.07388 times 10 to the negative 8 coulombs. But here in this lab, obviously, we got a different value being 2.268 times 10 to the negative 8 coulombs. And obviously, they differ. The line charge is, it's a more real example of the real value. It's closer to the real value, as it's really accounting for all the different charges being spread out instead of a point charge. Because all the values being spread out accounts for the forces between each different charge and the entire length of the tape in general. So that one is definitely closer to the real value, the length of